Mr. B. Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. So here I am having the theory of computation as a subject. Let me start with the recap of what we had seen in the previous episode of the same subject is concerned. So we have seen the recursively enumerable languages. So it is the as far as the hierarchy of Chomsky is concerned, this is a top level language which could be recognized by a Turing machine, and if you go beyond that, we have a class of language called non-recursively enumerable language, for which there exists no Turing machine. So if you want to prove that a language is going to be a recursively enumerable language, it is enough to prove that there exists a Turing machine for the language. Also we have seen a language called diagonal language. So the importance of the diagonal language is it has no Turing machine for its recognition. So we have seen how the diagonal language is formed from the various characteristic vectors of the Turing machines, and we have also seen the proof that the diagonal language is a non-recursively enumerable language. So that is what the that is topic we have seen as far as the previous episode is concerned. As far as today's episode is concerned, we are having the post correspondence problem. It's a very familiar problem which is an undecidable problem, and we need to prove that this problem is an undecidable problem. But let me start with what is the problem is, and then we shall see that is one example of the problem, how this PCP is formed, and afterwards we need to prove that this problem is an undecidable problem. And to prove this problem is undecidable problem, once again we will make use of the Turing machines. We know that LU, that is an universal language which is an undecidable that is problem, and LU can be very easily transformed into a Turing machine. So for that we need to have some reduction from this PCP to LU, that is your universal language. So it takes two steps. First we are trying to find out the MPCP, which is a modified post correspondence problem, and then we will go for transforming this modified post correspondence problem into PCP, and finally we will prove that PCP is undecidable. Let me start with the definition of what PCP is. Here is the definition. So we have an instance of PCP. So an instance of PCP means we will be given two lists of strings. So we may find that there are two lists are given, one is A and another one is B, and we have W1, W2 etc. up to Wk, and X1, X2 etc. up to Xk. So both the lists are called, that is A and B, and the size of both the lists must be same always. It means that if there exists k number of strings in this list A, then there should be exactly same number of strings as far as list B is also concerned. But whereas when you take the corresponding pairs, it means that the ith string from the list A and the same ith string from the list B, so if you take them together, which will be called as a corresponding pair, the corresponding pairs, that is strings available in the corresponding pairs, not necessarily be same. It is not even required that there should be a prefix match or proper match, nothing is required. But the total number of strings available in list A and list B must be same, whereas it is not required that the strings in the that is corresponding pairs should be same. So when you are given two lists of the form that is A and B, each with k number of strings, so now the question is, how do you find out the solution for this problem, or what is the meaning of the solution of the problem? So the solution of the problem means we need to find out a sequence of indices I1, I2, I3 etc. up to Im, but subject to the condition that if these sequence of integers are taken as the indices for the corresponding pairs, you just combine, that means concatenate the strings with the help of these indices. For example, if the index sequence is 2, 3 and 4, then W2, W3 and W4, the concatenation will give you a string from the list A, and from the list B, x2, x3, x4 combined together we will get another string, and if the string obtained by combining or concatenating W2, W3, W4 is same as the string obtained by combining x2, x3 and x4, then we can claim the sequence 2, 3, 4 as a solution for the PCP. It is not required that we must have the corresponding pairs with the same strings. So, in that case it is not so easy to find out the matching strings, that is W2, W3, W, that is your Wi1, Wi2 etc. up to Wim. So, here there is a point to be remembered, the number of strings available in the list A and B not necessarily be same as the number of corresponding pairs to be taken for finding the solution. The number of corresponding pairs to be taken for the solution can even be 1 or anything, but it should be a finite number, that is finite sequence of indices, whereas when you go for the corresponding list, that is list, the number of strings available in list A and list B are concerned, it is going to be once again finite, but it can be a very small list of strings, but whereas solution it can even be very lengthier one, or the sequence which is considered as a solution may be a lengthier one. So, the idea is just find out the corresponding pairs such that their concatenations as per the sequence, that is index sequence. If they are giving the same string on both sides, then the sequence is called the solution, and if you are not able to find out a solution, there is a chance for having a partial solution. The partial solution means a prefix of the concatenation of the list A is going to be the complete string available in the concatenation of the list B, or a prefix of the concatenation of the list B is going to be same as the string obtained by combining the corresponding, that is strings from list A. In either case we will call it as a partial solution, but it is not a complete solution. Most of the time we will be left with, that is partial solution, and keep going. So, keep on adding some, that is index sequence, we will be getting partial solution and the solution may not converge. That is, a partial solution will never be converted into a complete solution. So, if the solution for the PCP is converging, or we will be able to get a complete sequence of indices such that the string combined by obtaining list of strings from A and list of strings from B are going to be same, then we will call the solution as complete solution, and if you are always able to get only a prefix match, then we will call the solution as incomplete solution or a partial solution. So, if it is guaranteed to have a complete solution, then the problem becomes a decidable problem. That means, we are able to have a problem and whose solution is obtained, that is PCP is given for you, and we are able to get the solution for the PCP. It means that there is a solution for that, that is the problem is a decidable problem. But at the same time, if you fail to obtain a complete solution, but it means that if you are able to get only a partial solution, then the problem becomes undecidable. We get partial solution and we will not be able to decide even that the solution, the problem has no solution, because always there is a partial solution existing, and by appending the corresponding pairs, there is one or more sequence of corresponding pairs on either side of the list concatenation. Since we are getting always a partial solution, it keeps going, and we will say that the problem is going to be a undecidable problem. So, given the problem is actually given an instance of PCP, tell whether the instance has a solution or not. That is, you will be given an instance, it means two number of lists A and B are given, and we have to find out whether there exists a solution or not. If there is solution, it becomes decidable. If there is no solution, it becomes undecidable. So here we have an instance of a PCP. That is an example. The two lists are given, list A and list B are given for you. That is, in the list A we have the string wi, and in the list B we have the string that is xis. So we have the concatenation, that is pair number 1 is concerned, that is the corresponding pair 1 is concerned. In the string that is w, or in the list A we have 1, and the list B we have 3 consecutive ones, and in list A the second string is 1 0 1 1, and in the list B the second string is 1 0, and in the list A the third string is 1 0, and list B the third string is going to be 0. So in this case, if you are looking at the corresponding pair 1, we find that there is a prefix match, because 1 and the same 1 is here, but we have more symbols. So w1 is a prefix of this x1, so it can be a partial solution as it is. And once again, when you look at list A, the second string is 1 0 3 consecutive ones, the second string in list B is 1 0. So once again there is a prefix match, but it is the reverse direction. List B is going to be the prefix of list A. Still there is a partial solution which can be obtained by taking only the corresponding pair 2. But when you go for 3, we do not have any that is prefix match, because the list A string starts with 1 0 and list B string starts with 0, so there is no prefix match. It means that certainly we cannot have a solution starting with 3, as we do not find any prefix match as far as the corresponding pair 3 is concerned. But it is possible to start a solution with 1 or with 2, but the intention is to find out a complete solution. So when you take 1 as the first string, if you are combining, that is 2, with the corresponding pair 1, what will happen is the third symbol will become 0 in the concatenation, but whereas the third symbol in your list B inside there is concatenation is 1. So there is no match. It means that you can't have a solution starting with 1 followed by the corresponding pair 2. And the next one, if you start with 1, can we have the next corresponding pair as 3? That is also not allowed, because if you take 1 immediately followed by that there is a third one, then what happens is the third symbol is 0 once again, but in the second list the concatenation gives you the third symbol as 1, so no match. But whereas if you are starting with 2, then the 2 itself is a corresponding pair, which is a partial solution, because there is a prefix match, 1 0 1 0 match is there. Then followed by that you can combine the corresponding pair 1. So what will happen is 1 is appended as shown in the second table, 1 is appended as the end of the table, that is string which is on the list A concatenation. So now the list A concatenation is going to be 1 0 followed by 4 consecutive ones. When you take the first string from your list A, the entire corresponding pair must be used. It means the second string from list B should also be used, which is nothing but that is going to be 1 1 1. So now if you combine both the patterns, as far as list A is concerned, it is going to be 1 0 followed by 4 consecutive ones. In the case of list B is concerned, 1 0 followed by 3 consecutive ones, which means the list B concatenation is a prefix of the list A concatenation. So it is a partial solution, but it is not a complete solution, since there is no proper match of the concatenation from left side and the right side, of the list A concatenation and list B concatenation are concerned. So this is a partial solution. So when you look at the second, that is consecutive, that is corresponding pairs, we are taking once again the corresponding pair 1. It means the string which is obtained by combining the strings from list A is 1 0 1 1 followed by a 1, but whereas the second one is concerned, it is going to be 1 0 then followed by 1 1 once again 1 1. So now the number of ones, so number of symbols available on the list A concatenation is 2 4 6 1 7, but whereas in the case of list B it is totally 8 number of symbols are there. But we find a prefix match, which is the list A concatenation is the prefix of the list B. So, which means that still it is a partial solution, but when you go for combining it with 3, we find a complete solution. So, the solution for this problem is going to be the index sequence 2 1 1 3. So, as far as this instance is concerned, we find that there is a solution possible. So, this problem becomes a decidable problem. So, now we have another instance of the same problem, that is PCP, where we are having once again 4 number of that is corresponding pairs. So, list A has 4 strings and even list B is also having 4 strings, but this is a pair, this is a problem instance for which we can't find out a complete solution. That means we will not be able to find out a sequence of integers such that their concatenation in that order from list A and list B will never converge. Never converge means the concatenation of strings from the list A and list B concatenation will never be same. It means always we will be able to have a partial solution by appending some one or more number of corresponding pairs along with the already existing corresponding pairs, but no corresponding pair will go for terminating the string concatenation saying that both sides are equal, or the list A concatenation and list B concatenation are equal, which means this problem has no solution. So, here is the example. So, we have list A with that is the first string is 1 0 and the second one is 1 0 1 and the second string 0 1 1 1 1 on the list B. The third corresponding pair is 1 0 1 and 0 1 1. So, you can have a solution starting with 1, but we cannot have a solution starting with either 2 or with 3, as we find that there is no prefix match for those strings. But whereas in the case of a solution for this problem is concerned, we can start with 1, but when you go for the next one, you take 2 as the concatenation with 1, we find there is no match because the resulting string will be having a prefix of 100, which is not going to be possible when you are having the list B is concerned. So, whatever be the combination we are taking, so we will not be able to find out a converged solution. That means the strings on both sides or strings on the concatenation of list A strings and the list B strings will never be equal, but always it is possible to find out a prefix which is matching. So, for example, if I are taking that is 1 0 1 0 1 and we can go for 3, so it is going to be 1 0 1 0 1 and here also the prefix match 1 0 1 0 1. So, what remains is here it is 1 and here it is nothing. So, once again we can go for reusing this your 1 or even 2, so that we will be able to have some prefix match, but it will never be a complete solution. So, the problem now, if you are automating this problem or if you are making this problem to be solved by any Turing machine, it will keep on finding always a prefix match with corresponding pairs available from the list A and list B, but the Turing machine will never comes to a halt saying that the solution has been obtained. The Turing machine will keep on progressing by appending some prefix, there is indices where the corresponding prefix matches are there. So, these kind of problems are called undecidable problems. We will not be able to find out the exact solution, but always the problem is in move, there is no halt at all. So, this is an instance of an undecidable problem. So, now the question is modified there is post correspondence problem. So, first you should know what is the need for this MPCP. The intention is proving PCP as undecidable problem. To prove PCP is undecidable, we should be able to reduce the language LU in terms of the PCP. LU is the universal language, which we have already seen that it is an undecidable language. So, once we are able to reduce that LU into PCP, then we can claim that PCP is undecidable, but it is not straight away easy for transforming an LU into directly into PCP. So, we will go for a modified PCP problem, that is modified post correspondence problem, and it is very easy to transform or reduce LU in terms of MPCP, that is modified post correspondence problem. So, that is the reason why we move from the PCP to MPCP, and later we will study how an MPCP problem is transformed into a PCP problem. Actually, we need to learn even more than that, that is how LU is reduced to MPCP. So, that completes the proof for a PCP is undecidable. but as such now we need to study, that is how this MPCP is reduced to PCP. Before that we should know what is a MPCP problem. As far as PCP is concerned, if you are having k number of corresponding pairs, we can start with any corresponding pair at any point of time. So, you can start with the first corresponding pair, or we can start with the second one or third one or the ith one, but subject to the condition that there exists always a prefix match. But if you are looking at a Turing machine, there is always an initial configuration. So, we must start with only the start state of the Turing machine, but we can't randomly start from the any ith state of the Turing machine. So, that condition or that restriction we want to impose on our PCP problem. That means, we must always start with the very first corresponding pair rather than freely starting from any corresponding pair. So, what we should do here is, you transform the problem into a way such that there will be always provision for starting from the first corresponding pair rather than any ith corresponding pair. So, what this MPCP says is, we must start with the corresponding pair which is the very first one as far as the list A and B are concerned. So, if you are saying the solution for PCP, that is MPCP, then once again we will be saying the solution is going to be I1, I2, I3 etc. up to IM, but subject to the condition that it is not the concatenation of only WI1 to WIM should be equal to XI1 to XIM, but we need to go for taking the prefix, that is W1 and X1. That is, actually as far as PCP is concerned, we take only this pattern from WI1 to WIM, but whereas in the case of MPCP is concerned, we will be always adding the prefix W1 here and X1 here. So, this concatenation, your W1, WI1, WI2 etc. WIM, if it is equal to X1, XI1, XI2 etc. up to XIM, then we can say that the solution is I1, I2, I3 etc. up to IM, but we will never include 1 as part of the that is solution. Even though we include that 1 is always part of the solution, 1 is the prefix for the entire, that is concatenation, we will not include 1 as the part of the solution, because it is implicitly required that we must always start the solution with the first corresponding pair, but we will account only the sequence of indices which are included other than the first corresponding pair to form the solution. So, this is about your MPCP, where it is the solution is we must start with, or the difference is here we must start with the first corresponding pair, which is not a restriction as far as the corresponding the PCP is concerned. So, now the question is how this MPCP gets reduced into PCP, then only it will be convenient for us to prove that PCP is an undesirable problem. So, what we need to do for that is, PCP has no restriction, but MPCP has restriction. So, we must introduce, there is explicit constraint available in MPCP into an implicit constraint in PCP, which means once an MPCP has been transformed into a PCP instance, the PCP should not be able to start from any position or any corresponding pair other than the first corresponding pair. That is, we are implicitly forcing that PCP to start from the first corresponding pair. So, if that restriction has been there in PCP, then we can say that MPCP and PCP are equal. So, that transformation here we are going to study. So, we will be having another 2 number of lists. So, those lists are called that is C and D. Actually, what we are given is A and B are given. Now, we need to form C and D. So, if there are k number of pairs available in A and B, we will be having k plus 2 number of pairs in C and D. So, the k plus 2 number of pairs are starting with 0 and going up to the index called k1. That is, in the case of list C, the corresponding strings are y0, y1, y2 etc. up to yk plus 1, and in D, which is an equivalent for B in your MPCP instance, the PCP has D where it is z0, z1, z2 etc. up to zk plus 1. So, now the question is how these 2 pairs or how these 2 lists are constructed from an MPCP instance. So, the first one y0 is taken by copying y1 with the prefix star. So, star followed by y1 is nothing but y0 and your z0 is going to be z1. So, simply copying z1. So, this is the first that is statement or first condition for transforming MPCP an instance into PCP instance. And the last one is how do you form the k plus 1th pair in C as well as D from A and B. The y k plus 1th string is simply dollar and z k plus 1 is star dollar. So, this is how we will be forming the last pair available in the equivalent PCP from the MPCP. Then in between what we will do? It is going to be the strings y1, y2, y3 etc. up to yk and z1, z2, z3 etc. etc. up to zk. So, those strings are to be obtained from w1, w2 up to wk and x1, x2 etc. up to xk. First you look at the very last first line in the second point. So, yi be the wi with a star after each symbol of wi. That is, take a string from wi provided your index I is from 1 to k. If you are taking the string called for example w2, after each symbol available in w2 you put a star. So, now the resulting string is going to be your y2. Then whereas in the case of x is concerned, it is before each symbol in x2 you put a star. So, if it is going to be the transformation from w to y, after every symbol in wi you put a star. If it is from xi to zi, then before each symbol in xi you put a star. So, it is for every symbol we must do that. So, if you do it so, we will find that a new list from A and a new list from B are formed, which are named C and D. And if you look at that instance, that is your PCP instance which is obtained from your MPCP, we can have a solution for that PCP only with the very first corresponding pair as the first pair. We cannot start from anything other than that. It is because of this transformation we will be having that constraint always there. We shall see one simple example. Here we have an MPCP instance. So, we are having wi and xi. So, that is what the list of strings available for us, and from here we are forming the PCP. Already I told you that if there are k number of pairs available in the MPCP, there will be k plus 2 number of pairs in the corresponding PCP. So, what will happen is first you have to form y0. So, y0 is obtained by star followed by y1. The star is here and y1 is 1 star. So, we will be having star 1 star, but z0 is simply obtained from z1. And when you go for yk plus 1, it is dollar and zk plus 1 is star dollar. And rest of the strings are concerned, that is your y1, y2, y3 and z1, z2, z3 are concerned. As far as y1 is concerned, after each symbol put a star. So, here it is first symbol is 1, put a star. So, we are having 1 star, and here it is 1 0 triple 1 is there. So, 1 star, 0 star, 1 star, 1 star and 1 star we are getting. And then in the case of corresponding pair 3 is also concerned, we are having 1 star and 0 star, but whereas in the case of z1 before each symbol you put a star. So, it is before there is 1 and once again before 1 and once again before 1 you put a star, that is star 1 and star 1. So, you will be having a corresponding that is pair with 0 star 1 and star 1 and star 1. So, this is to be followed for rest of the strings. So, now if you are looking at this particular instance PCP, you can take the first example, there is first pair, there is 0th pair number 0. It starts with star 1 star in y0 and correspondingly z0 is star 1 star. So, there is a prefix match. But if you go for the corresponding pair 1, it starts with the 1, the second one starts star, no match. Here it starts with the 1, starts with the 0 here, star here, no match. Here it is starting with the 1 and starting with the 0 star and there is no match. Even 4 is concerned, it starts with the dollar, but whereas in the corresponding list D it starts with the asterisk. So, we are able to find out a corresponding that is problem, that is our MPCP has been reduced into a PCP instance, but we find that there is no possibility for having a solution without starting the solution from the corresponding pair 1. So, that is how we are showing the MPCP as reducible to PCP, and now your PCP is a problem which can be very well that is suited for your Turing machine problem, that is called LU, where the Turing machines are always expected to start with the very first starting state, that is nothing but Q naught. So, to summarize, we have studied the post correspondence problem, and then what is the meaning of the PCP. Then we have seen that is what is going to be the modified PCP problem, that is MPCP, what is the need for that, and also we have seen with the help of an example how we are reducing the MPCP into its equivalent PCP. So, as far as question component is concerned, so we will maybe asked to that is prove that the MPCP reduces to PCP, and what is the meaning of a PCP instance, and you will be even asked to find out the solution for PCP given an that is PCP instance, which means that there will be two lists are given for you, and you may be asked to find out what is going to be the solution for this problem, or you will be asked to find out whether there exists a solution available for that or not. So, if there exists a solution, we can find out that. If there is no solution, we can always guarantee only a partial solution. So, this is about your PCP and MPCP. So, with this I conclude this episode. Thank you all.